In this video, I'll be using 4-story building with an external elevator core. The lateral force resisting system consists of intersecting moment frames. The elevator core is structurally isolated. The building will have a maximum beam depth not exceeding W18 beam to allow sufficient clearance for ductwork running beneath the beams. Starting a new model. In this step, the story height and girds are set. Then a list of sections that fit the parameters set by the architect for the design is defined. Choose the Use built-in settings with option. For this tutorial, I'll use AISC 360-10 steel design code and ACI 318-11 concrete design code. Make sure to use the design code designed for your region. After setting up the model initialization, press OK. After that, you'll get a new window, the New Model Quick Templates form. The form is used to specify horizontal, grid line spacing, story data, and template models. Template models provide a quick, easy way of starting a model. They automatically add structural objects with appropriate properties to the model. It is recommended that you start your models using templates whenever possible. However, in this example, the model is built from scratch, rather than using a template. Observe that measurement input boxes automatically convert your input units to the specified unit for the box. For instance, inputting 180 inches in a field box for feet automatically converts the value to feet, in this case 15 feet. After setting up this template form to your needs, click OK to proceed to the ETAB's model design window. Observe that we have two windows, a plan view window and a 3D view window. Ensure that you click on the window you want to work on before taking any action. Click the View button on the menu ribbon, and then set Display Options. This Set View Options window allows you to set your display preferences. On this editor window, we have Display Title tab, Coordinate System, Similar Stories, Current Units, Model Explorer, Menu tab and Function Shortcuts. Now, let's create our grid system. Grid settings depend on the architect's drawing, and act as a guide for column and beam positioning. An auto-select selection list is simply a list of sections. Auto-select section lists can be assigned to frame members. When an auto-select selection list is assigned to a frame object, the program can automatically select the most economical, adequate section from the auto-select section list when it is designing the member. In this design, we'll use beams no deeper than W18. It is useful to create an auto-select section list that contains W16 and W18 beams. In this Frame Property Shape Type window, you can define the shape and properties of your steel. Remember that we require W16 to W18 beam sizes for our auto-select list. To choose W16 through W18 sizes, left-click on W16, scroll down to W18, hold the Shift key on your keyboard and left-click on W18. You can bring up your Model Explorer tab if it isn't there already. Right-click on the frame sections to add new frame property. For the section shape drop-down list, choose Auto Select. In my property name for this list, I'll use the short form of Auto Lateral Beam. The sections we chose earlier will appear in the available section list. Go ahead and select the W16 to W18 sections, and add them to the auto-select list, after which click OK. In this section Property Import Data, we only need a comp BM and a lat col. To make this selection, select a comp BM, then press and hold the Control key, then select a lat col. Ensure that the plan view is active. When a view is active, its title will be highlighted. To ensure that any changes we make in a story are simultaneously created on the other floors, choose Similar Stories in the drop-down. You can also review current story definitions. When similar stories is selected, all changes and additions will be updated in stories that have been designated to similar story. If a story is set to none, changes on other stories won't affect it. The Draw column is used to indicate the positions of columns in a model. You can place your cursor on a shortcut icon to get its description. You can draw your columns by clicking where you want them, or drawing a selection box over grid nodes you want them to be placed. To deselect tools at any time, press the Escape button on your keyboard or the Select Object icon. Supposing we placed the angle of some columns wrongly, this is how we can correct that. Hold down the Control key on your keyboard and left-click once in the plan view on column A2. A selection list pops up because multiple objects exist at the location that was clicked. This form will only appear when the Control key is used with the left click. Select column from the list and click OK. For this example, I'll repeat this action on columns B2, A3, C3, and C4. On the frame assignment, we can change the angle of the columns. Use the set display to choose the details you want to see in your model. Ensure that you save your model. You can save it with a different name instead of overwriting previous versions. This will enable you to keep records of your various stages. To draw the lateral force resisting beam objects, use the Beam tool. The property should be AutoLat BM. Recall that this property is the AutoSelect section list we created earlier. To draw a beam, you can click on the grid lines, or you can draw a selection box over the grid lines where you want your beams drawn. Since the similar story is selected, changes you make on the current story will be updated on the rest stories. In this model, we do not want the beam extending from column C2 to C3. To delete this beam, we'll select it and use the delete icon as illustrated in the video to delete it. To draw the composite beam, ensure that the A-Comp BM is selected in the tool properties. Make sure that the approximately orientation item in the properties of object form is set to parallel to Y. Left-click within the frames to draw the composite beams, or draw the selection box over the frames where you want your composite beams to be drawn. To remove composite beams, use the intersecting line tool to select the beams. Left-click and draw the selection line to intersect the beams for deletion. Once your selection line intersects all objects you wish to select, double left-click to select them. Press the Delete key on your keyboard to delete them. To draw the floor, select the Floor or Wall tool. Ensure that Deck 1 is selected in the object properties. To make a more accurate drawing, activate the Snap to Grid command. Start drawing the floor by left-clicking grid joints along the perimeter of the floor area. You can review the floor data in the Deck Property Data form and make the required changes. Next, we'll add exterior cladding for wind load application. Exterior cladding consists of dummy shell objects that have no mass or stiffness. The areas will be used to apply wind load to the building. Use the Auto Draw Cladding tool to create the walls. In the Set Display Color form, you can choose different view color and transparency for your model objects. In designing the external elevator core, we'll use the Wall Stack tool. You can manipulate the wall stack however you want, before placing it in your model. Click on the Plan View window to activate it. The static loads used in this example consist of the dead, live, earthquake and wind loads acting on the building. An unlimited number of load patterns can be defined. This example also applies an ASCE 710 static earthquake load to the building and an ASCE 710 wind load to the building. The forces that are applied to the building to account for the earthquake and wind load are automatically calculated by the program. Note that there are two default load patterns defined. They are dead, which is a dead load, and live, which is a live load. The self-weight multiplier is set to 1 for the dead pattern. This indicates that this load pattern will automatically include 1 times the self-weight of all members. This will be the setting for our seismic loading. After defining the static load patterns, click OK. In this step, the superimposed dead and live gravity loads will be applied to the model. Make sure that the Similar Stories feature is enabled and that the plan view is active. Click anywhere on the deck, but not on a beam to select the deck. A dashed line should appear around the perimeter of the deck. This dashed line indicates that the deck has been selected. If you make a mistake in selecting, click the Clear Selection button, or the Escape key, and try again. The status bar in the lower left-hand corner of the main ETABS window should indicate that your shell objects have been selected. On this shell load assignment uniform form, we'll assign gravity dead and live loads on our decks. Note that the direction of the gravity load is negative. This is because the gravity load direction is downward, and in a negative global z-axis direction. At this moment, we'll assign loads to our frames. Now, let's define a developed elevation. To develop an elevation, use the Draw Developed Elevation Definition command. Name your elevation, and then, click OK. With your Snap to Grid command selected, click along on the grid joints in the pattern shown in this video. Press the Enter key on your keyboard once you're done. Note that the developed elevation is outlined in the 3D view. In this step, wind loads are applied in the X direction to the exterior cladding along grid line A and the developed elevation created earlier. Typically, wind pressure coefficients are applied to the vertical surface of a shell object. In such cases, and in this example, a positive wind pressure coefficient applies wind load in the positive local 3-axis direction of the shell object. A negative wind pressure coefficient applies wind load in the negative local 3-axis direction of the shell object. ETABS automatically generates load cases for each of the previously defined load patterns. Review and verify that the load cases are appropriate, and then click the OK button to exit the form. When the entire analysis process has been completed, the model automatically displays a deformed shape view of the model, and the model is locked. The model is locked when the Unlock Model button appears locked. Locking the model prevents any changes to the model that would invalidate the analysis results. Before designing the composite beams, ensure that you have used the Analyze command for the model. ETABS will use the sections defined early in the design. In this window, ETABS will show you the list of acceptable steel sections for your design. Ensure that you save your model. You can save it with a different name instead of overwriting previous versions. This will enable you to keep records of your various stages. The warning message indicates that the analysis and design sections are different. Click the No button to close the form. Repeat the process from the analysis step until the analysis and design sections are the same. To locate the step in this video, use the video markers in the description. If you don't get this message, rerun your analysis. Welcome to the second part of the ETAB tutorial. In this part, we'll be designing a concrete building. This example project is a 6-story building. It'll have 12 feet high floors. The lateral force resisting system consists of perimeter concrete moment frames with interior shear walls. The beams are 24 inches wide by 30 inches deep. The building will also be loaded with an additional dead load of 25 pounds per square foot for partitions and equipment, along with a live load of 80 pounds per square foot for both the floors and roof. Lateral loading will be wind loads based on the ASCE 7-10 code. In this window, you can set model units, steel section database, steel code and concrete design code. Make sure to do your research on the suitable code for your design region. For this example, I'll be using the built-in settings with the displayed options. In this new model quick template, we can specify the number of stories, grid information and structural objects. It is recommended that you start your models using templates whenever possible. I'll use the flat slab with perimeter beams option. I'll set the drop panel size to be 6 feet. Ensure that the section shape is rectangular. Change the property name to concrete column and set the section dimension to the required size. You can adjust these properties if needed. In this form, we will define the beam properties. Verify that Slab 1 is selected from the Slab drop-down list in the Structural System Properties area. Slab 1 is a default 8 inches thick slab section. Ensure that Drop 1 is selected from the drop-down list. Drop 1 is a default 15 in thick slab property. In the load area of the Structural Geometry and Properties form, type 25 inches in the Dead Load Edit box and 80 inches in the Live Load Edit box. Verify that the Rigid option is selected in the Floor Diaphragm Rigidity area. This option removes in-plane diaphragm deformations. The Flat Slab with Perimeter Beams button should be highlighted with a dark blue border. Click the OK button on the New Model Quick Templates to display the model. Make sure that the plan view is active. Change the one-story option to all stories. Click the rectangular floor tool. Change the object property to opening in the drop-down list. Ensure that the Snap to Grid Intersection and Point command is active. This will assist in accurately drawing the shell object. This command is active when its associated button is depressed. In the plan view, click once at column C3, and while holding down the left mouse button, drag the cursor to column D2. Release the mouse button to draw a rectangular opening. Hold down the Control key on your keyboard and left-click once in the plan view on column C3. A selection list pops up because multiple objects exist at the location that was clicked. The selection list will only appear when the Control key is used with the left click. Select the column from the list by clicking on it and then on the OK button. The column at C3 is now selected, as indicated by the dashed lines in the 3D view. It is selected over its entire height because the All Stories feature is active. Note that the status bar in the bottom left-hand corner of the main ETABS window indicates that 6 frames have been selected. Repeat this selection process for D3, D2, and C2. Delete the selected columns because no columns should exist at these 4 locations. Using the Wall Stacks command, we'll be drawing a wall stack in the void floors. Make sure the angle is at 90 degrees. The static loads used in this example are wind, dead, and live loads. If the Model Explorer isn't displayed for you, use the Options menu to activate it. Note that the dead and live load patterns are already defined. Let's go ahead and define the wind load. Ensure that the exposure from extensive rigid diaphragms is selected. This means that the program will automatically calculate all the wind load cases as prescribed in the ASCE 710 code. You can view the different wind cases too. Verify that linear static is selected in the load case type drop-down list. Verify that wind is shown as the load pattern in the loads applied area. Select the Use Preset P Delta Settings option in the P Delta, Nonlinear Stiffness area. On the Preset P Delta Options form, select the Non-Iterative, Based on Mass option in the Automation Method area. This will add P Delta effects to the analysis. Having this message indicates that the model has no connectivity issues. Clicking the Run analysis will cause the program to create the analysis model from your object-based input. After the analysis has been completed, the program will automatically display a deformed shape in the 3D window. You can use this form to display the wind load deformation of the building model. Each of the deformed shapes due to the 12 different wind load permutations, as specified by the ASCE 710 code, may be viewed by clicking on the VCR buttons. Verify that the design code drop-down list is set to the appropriate design code and review the design parameters as well. When the design is complete, the longitudinal reinforcing is displayed on the model. This form shows the required reinforcing steel calculated for each design combination at different locations along the length of the beam. The largest reinforcing value, either top or bottom steel, is highlighted. This report shows detailed design information about the beam. This message indicates that the shape and reinforcing of all concrete frame members are adequate. In this step, we'll be designing the shear walls. Review the design parameters shown on this form and then click the OK button to accept any changes made. The program designs the shear walls, specifying the required reinforcing based on the shape and size of the members defined earlier. A table summarizing the design of the shear wall piers will now appear in a window as shown in this video. Now you have completed the introductory tutorial for ETABS. If you did find this video helpful, don't forget to like this video, subscribe to this channel and turn on the notification to get notified on future uploads.